Hello everyone, today we are going to talk about solar storms. Now you must have read recently in news about solar storms and how it might cause blackouts. So the idea of this video is not to go into complex physics regarding solar storm, but will only focus on the basic origin of solar storm, how it comes around, how it interacts with Earth, and what are the effects it has on our life, the impact it has on us. So before getting into solar storm, let's understand what is solar wind. So just like Earth has a wind constantly blowing around in the atmosphere, similarly in the solar system, there's a solar wind blowing. Now this solar wind is not exactly like the wind on Earth. So because in the space the particle density is very less. So like on Earth, the wind consists of gas molecules, dust, aerosols, and any pollutant that is there. In the solar system, this solar wind generally consists of charged particles. Now, where do these charged particles come from? They come from our sun. And the particle density is very less. So keep in mind, when we say solar wind, it's not the wind that is blowing on our planet Earth. So they are different kind of winds. So let's look at how solar winds were first discovered. So around in 1950s, a scientist, he saw that comets which are traveling in our solar system, let's say a comet is traveling in that direction, another is traveling in this direction. So what he assumed was that the tail of these comets will be opposite to the direction of their motion. So this is what he was expecting. But what he noticed was the tail of the comet was always pointing away from the sun. And this gave birth to the idea that, okay, there's something that is pushing these comets away from the sun. And then the concept of solar wind was born. So now coming to how solar winds are formed. So this is where there's some physics there, and I'll try to keep it as simple as possible. So sun is very hot. The surface temperature is around 6,000 degrees. The corona, that is sun's atmosphere, this temperature is around 1 million. And now the name corona is not after coronavirus. Actually, coronavirus is named after sun's corona because their structure seemed very similar. So now corona is at 1 million, the surface is at 6,000, and then the interior is hotter with the core going as high as 15 million. So now what happens is, at such extremely high temperature, the sun exists in a fourth state of matter which is called plasma. So this is nothing but ionized gases. Ionized gases is where the charges are separate. So positive charge and negative charge are separate. Now due to such high temperature, this plasma constantly moves in the sun. That means the charges are moving. Now you must have read in your class 10th physics, or even if you haven't read it, just know that moving charge always creates a magnetic field. So this plasma which is moving inside the sun and on the surface in the corona, it causes a magnetic field, and it is this magnetic field. So now these particles, because they are so hot, and sometimes let's say corona also has plasma, and some plasma from here they reach here, and then the gravity of sun is not high enough to pull them. The velocity of these particles are really high, so they start traveling around the magnetic lines of the sun. Because they are charged particles interact with magnetic field lines. Now the sun's magnetic field is spread throughout our solar system, so it goes far beyond our planetary system, that is Neptune, and thus this is how solar wind encompasses our entire solar system. Alright, so the key takeaway is that solar wind is not exactly like the wind on Earth. It's more like a stream of charged particles, and it has its own magnetic field attached to it. Now these charged particles, they travel along the magnetic lines of the sun, which covers the entire solar system. Now what is a solar storm? So just like on Earth, when we have a strong wind, we call it a storm, okay, a cyclone. Similarly, solar storm is when the solar wind is very intense, when the velocity is very high, when the number of charged particles are very high, we call it solar storm. So how do they occur? So there are a few reasons for solar storms to occur. Now we'll look at a feature on sun called sunspots. So these dark spots on sun, they are called sunspots. And these spots are dark because they eject particles. And when they eject particles, these particles, they carry some heat from the sun, and that's why these spots, they appear dark and they are called sunspots. So from the sunspots, generally sun emits particle, and these particles, they travel faster, they have more charge, they have more higher magnetic field due to higher charge, and it is these particles that cause solar storm. Okay, now this ejection can happen from sunspot, or this ejection can happen from corona as well. Then it is known as coronal mass ejection. And another interchangeable term that is used is solar flare. So when these dark spots, they are pointing towards our planet Earth, and their ejection event happens at that time when these sunspots are pointing towards Earth, we feel the solar storm. So now let's come to how solar storm reacts with our Earth. So here you see the Earth's magnetic field. These red lines, they are part of Earth's magnetic field, and this is how the solar wind interacts with it. So on the sun side, so here we have sun, our magnetic field is highly compressed. Okay, so the magnetic field of the solar wind, it compresses our Earth's magnetic field. And on the opposite side, that is when we have, like where we have night, this magnetic field extends backward, okay, and it's known as magnetotail. So now generally, like in the absence of a solar wind, our Earth's magnetic field should look something like this. Okay, it should be symmetrical either ways, but when there's solar wind, this side is highly compressed, whereas this side is elongated. And this entire arrangement looks like a bow shock, so it's called bow shock. So the shape of Earth's magnetic field is a bow shock shape. However, notice here, around the poles where the magnetic lines originate, there's a hole. Okay, and at these places, the solar wind, that is the charged particles, they can enter our atmosphere. And that is why if you would have seen the effect called aurora borealis, also known as northern lights, so they are observed around poles, usually above 60-degree latitudes, because this area is not as highly protected as the areas around equator, and that's why we see aurora effect in night at the closer to poles. And when we have, like, this is when solar wind occurs. When we have strong solar wind, that is when solar storms hits us, this magnetic field line may sometimes, like this, can get highly compressed. So Earth's magnetic field greatly weakens when an strong solar storm event occurs. But usually these storms, they pass in 5-6 hours, and then after they pass, Earth starts to regain its original magnetic field shape. So now coming to impact on Earth. So we have seen how solar wind interacts with Earth's magnetic field. Now what is important to note here is what are its effect on our lives. So when you read the news regarding the recent solar storm which was going to hit Earth last week, you would have read the first thing as it may cause blackout. So it can happen because our electrical system, they depends highly on electromagnets, and transmission line also depends on electromagnets. And since solar wind or strong solar storms, they have magnetic properties. So these charged particles, they are moving, so they have magnetic property. And if the storm is so strong that it is able to enter our Earth's atmosphere, and if it is able to come close to the surface, it can affect these electromagnetic equipments, causing them to malfunction, and that's why it can result in blackout. So this event actually happened in 1989 in Quebec, Canada, where there was a 9-hour long blackout. So imagine if something like that happens today, the economic loss due to it. So second is it can affect satellites negatively. So it can cause them to malfunction, or the transmission of signal may get disrupted, and we are highly dependent upon satellites. So our GPS technology, our internet, or even TV communications. So all these things can get impacted due to these solar winds. So like a similar event happened in 1859 in London when telegraph lines they developed faults due to a very strong solar flare that hit us. So communications line may get disrupted due to solar storms. Next impact is, so we are talking about auroras. So as I said, they are generally seen over 60-degree latitude. But if a storm is strong enough, Earth's magnetic field gets so weakened that these auroras can be seen as low as 40-50-degree latitudes as well. The next is life of astronomers. So they can be threatened. So astronomers are going to space. They are already less shielded than people on the surface of Earth. Now they do wear protective equipments, but if a strong solar flare hits Earth, these astronomers, their lives can be threatened due to it. And that's why NASA and other space agencies are working extremely hard to figure out when solar storms are going to hit us, so that they can time the launches of these spacecraft which carry astronauts to space. Or some other effects that you can probably guess is, let's say, airplanes. They rely highly on satellite navigation, GPS. So their traveling may get impacted. Recently, you would have read about Tesla cars. If the GPS fails, I don't know what Tesla cars would do. So yeah, these are some of the effects that they have on our life. And one more thing I didn't mention earlier, so let's come back here, is the sunspots on sun. Okay, so these are the sunspots. So there's a solar thing called solar cycle. It is on average a 11-year long cycle, but we have observed a shorter and a longer cycle as well. So every 11 years, sun goes from a solar maxima to a solar minima. And during the maxima, the sunspot activity is at its highest, and during the minima is at its lowest. So during solar maxima, we observe more solar storms than during the solar minima. So yes, this is it for this video. I hope this concept of solar storm was clear to you. Thank you. Have a good day.